I want to talk about advanced planning and scheduling solutions, and specifically about Siemens PreActor. PMC is a reseller and configurator of Siemens PreActor, which is the leading advanced planning and scheduling solution to the manufacturing industry. Like PMC, it has a worldwide presence. Now, before talking about PreActor specifically and its differentiators, I wanted to talk about what we mean by scheduling and talk about the advanced production scheduling cycle. In a typical scheduling system, the new orders are loaded and the current status of the facility, be it job, shop, factory, food processing plant, that is captured, and based upon the new orders and the current status, the automated algorithm following APS rules can generate a schedule. Now, before simply accepting that schedule and issuing it to the shop floor, we want the production control team to have agency, to be able to review different scenarios, to carry out what-ifs. They may carry out what-ifs because they may see an opportunity to improve upon the existing schedule. They may do so because they get a late breaking call from the sales team. Hey, we've got a potential new order coming in that could be delivered next week if we can take that order. Well, all right, what if we add that order to the automated orders? Can the facility still attain its schedule? So that's the sort of scenario that a production control team might want to review. They can use statistics also to analyze schedules, to look at schedule attainment, to look at utilization, to look at operating costs. One need not simply print out 2 sheets of paper with blinding rows and columns of production operations to say, well, both of these look good. I'm really not sure how to compare. No, there are objective ways to pull statistics, analyze schedules, and to say, at the end of the day, this particular schedule or that particular schedule is preferable. Once that decision has been made, the schedule can be released, reports may be printed, others might be displayed on screens throughout the plant. Internal systems monitor the progress of the production orders and the status of machines. And then at some point in the cycle, which could be the end of a shift, the end of a day, or even the end of a week or month, we begin again at the top of the loop. So that is going to be the overall flow of the advanced production scheduling cycle. Now, there are frequently encountered scheduling challenges that lead companies to opt to automate their scheduling. And again, I say opt because often when facilities are first constructed or when companies are first ramping up, they might not have automated scheduling. They might simply have 1 or 2 subject matter experts who schedule on a whiteboard or an Excel spreadsheet. The need for automated scheduling, advanced planning and scheduling, results from what we call a good problem. The problem being that the facility and or the company has reached a level of success such that production control people simply can't generate a good schedule in reasonable time without automated assistance. There's too many variables. So They want to retain a company typically like PMC and a software perhaps like PreActor in order to help them deal with this good problem. And specifically, some of the challenges that they're going to want to address are the need to adapt quickly to growing and also fluctuating demand. When demand is steady week over week, month after month, one might know a production schedule or settled on one that more or less works, but demand is almost never that steady. It grows, it fluctuates seasonally. Again, the production control team needs to publish schedules in limited time. If the shop floor needs a new schedule every shift, but the production control team, relying on their own devices, takes 2.5 days, well, then by the time it reaches the floor, it's completely obsolete. So the benefit of automation is to compress that and to make sure the schedule reaches the people who need it in a timely fashion. One wants to prevent over or underutilization of resources, typically, to balance production across multiple lines or multiple workstations. Another important function in automated scheduling is helping to reduce labor costs by right-sizing the workforce and controlling overtime. And interestingly, when people think about reducing labor costs through production scheduling, they often think of the second one first. They think one of the reasons we need production scheduling is advanced production scheduling is because we wanted to attain the schedule, on in 5 days or 6 days in 2 shifts, but because material was piling up at different areas of the plants, we had to add another shift. We had to work that 7th day. So how can we schedule production more efficiently? How can we control overtime? And that's legitimate. But we also have customers who say, look, even if we're talking about standard time, I really want to know how many people I need on any given day. My demand is fluctuating, meaning my utilization of resources and workstations is fluctuating, meaning I would like to be able to flex my workforce so that I really have the right number of individuals at any given day, at any given shift. And I neither have people standing around with nothing to do, nor do I find myself in an understaffed situation where people are running around like crazy trying to attain an unattainable deadline. Help me right-size my workforce, even if I'm just talking about standard time. So we can reduce labor costs in that way. We can help size batches and sequence the production in systems with product mix issues. There are often situations where we have what are called sequence-dependent changeovers, where it's relatively time-consuming to change over from product B to product A on a given workstation. So if we sequence smartly, and in the middle of the day we change over from A to B, instead of B to A, we reduce changeover time and we produce a more attainable schedule. And with that, we can reduce work in process inventory. There will be less material sitting in buffers, waiting for the workforce to get around to it, waiting for the changeover to complete. So there's a lot of challenges that advanced planning and scheduling can help a facility and help a production control team meet. An advanced planning and scheduling system should integrate tightly with ERP and MES systems, and that's what Preactor does. And typically the ERP system, we think of it as residing above the scheduling system in a sense, and feeding orders to the scheduling system and notifying the system of material availability. The manufacturing execution system, in a sense, sits below PreActor down at the level of the shop floor. And it is going to report back to PreActor how orders are progressing, those that have been previously scheduled. If there are breakdowns, if there are outages, a good MES system can also report that back to PreActor, and PreActor can in turn revise the schedule for the next shift accordingly. So the result of these calculations are, on the one hand, detailed schedules that go to the shop floor to describe what needs to be done and when, operation by operation, and high-level schedules that go to the ERP system to say, well, here's when order 100 will be ready to ship. Here's when order 102, 103, 104 will be ready to ship. And that, in turn, helps your shipping and your logistics people know when to have transport available and so on. So we want to be able, any system wants to be able to do this, and any integrator should be able to do this. And again, that's one of the things that PMC brings to the table with its wide range of engineering expertise. We not only have industrial engineers who can analyze the shop floor and understand your particular production scheduling needs, we have an IT department that is experienced with the processes and issues surrounding integration to help you do this successfully. And then, by connecting your systems, the APS system, to the ERP and MES and shop floor data collection, we can help you monitor the state of the execution against the plan, revise it accordingly, and produce and attain the desired throughput successfully. PreActor does these things particularly well because its calculation engine creates plans and schedules in seconds or minutes. It's smarter because it can identify and flag potential problems and help production control fix them before they happen. And as a result, we see that a lot of PreActor customers report improved customer service, inventory reduction, cycle time reduction, and increases in productivity. All this owes to the fact that PreActor is a family of products that are competitively priced, technically superior to its competitors, customizable for any type of planning and scheduling requirement. We've got a long track record and a broad install base and the availability of many case studies. And with local support in every region of the globe, implementation, training, and post-go-live support can be offered to any company in any language that is called for. I want to give you a look at some of the PreActor screens. These are, as the caption says, powerful, flexible, and they can be tailored to fit your needs. We can list orders in the PreActor interface that feed from upstream systems, and also supplies of materials. Those, in turn, are fed from upstream systems. And the availability of particular parts or materials can influence the sequence of order completion on the shop floor. Every particular product can have a unique routing with a specific name that can be assigned to a resource or group of resources. And then as we drill down into these records, we can find the very specific information about setups times and processing times and so forth. We could also revise the information directly in the screens, but generally we don't. Generally, that because that would constitute a very burdensome data entry task. Generally, we rely on the upstream systems to feed and maintain this data, the resources, the products, the customers, the routing. But we always have visibility, and we empower production control so that if they do need to make a change on the fly, if, for instance, a particular operation is performing more slowly than expected per day, this day, they can make that change on the fly and account for the contingency. PreActor schedules around constraints that matter to your business, such as the cost per hour of different resources, the availability of different types of equipment, the availability of labor, the availability of tools. Sometimes there's limited fixtures or dies, and since those can constitute a constraint on the system, PreActor can track those and make sure that those fixtures or dies or tools are not double booked for any time frame. Even power constraints, and from time to time this is a significant issue that can arise if certain facilities try to run on all cylinders. They can strain the local power grid or exceed the capacity of their generators. So as a matter of fact, as they incrementally add activities, they want to track the load, the electrical load, and want to make sure that they don't exceed a certain limit. And by the way, as we can see, this limit might even change. When it comes to our tooling constraints, we've got one of these grinding fixtures, and all the time we have one grinding fixture. Either it's in use, as we see from the green bar, or it's not. Whereas with our electrical constraints, well, for instance, during summer months, there may be periods when less electricity is available because the grid is supplying more electricity for air conditioning, either to the facility or to the surrounding community. So these constraints might vary over time, and PreActor can take that variable constraint, as represented by the red line, into account as well. It's a very powerful system. All of these are things that a human being can think of, but it's difficult for a human being to juggle all these constraints at once. That's the power of the computer. That's the power of automation. One thing I alluded to was sequence-dependent setups. There may be particular setup times between individual products or between families of products that are particularly difficult. So for instance, here we say whenever we go from a product of a given family to that of the same family, family 1 to family 2, pardon me, family 1 to family 1, family 2 to family 2, 3 to 3, and so forth, there's no changeover. But as we change product families, there's going to be a 10-minute sequence-dependent setup. By the way, this could vary. In some cases, this could be 20 minutes. It could be 30. So you want to get the optimum utilization out of your facility by sequencing in order to reduce setups. And so here we see a schedule that's more or less sequential. Give me family 1, 2, 3, 4, and really does not optimize the sequence, where in this case they do. And pardon me, the sequence, these 1, 2, and 3, and 4, these concern order numbers. The colors are what key back to the families. My mistake. So as we can see, when we group the colors together, when we group the families together, we can realize the maximum set of production, which results in the maximum utilization and maximum attainability. The schedule can be created in a way that works for your business. Some businesses prefer to schedule using a forward algorithm, some using a backward algorithm, some using what's called a bottleneck algorithm, where the bottleneck operation, often somewhere in the middle of the process, is scheduled first, and then the APS system, which is to say PreActor, schedules forward downstream of the bottleneck and backward upstream of the bottleneck. We can focus on the criteria and attributes that are important to you, and PMC can also create customized APS rules. There's a lot of stuff that ships with PreActor right out of the box, but that is by no means an exhaustive list, and we absolutely, upon listening to you, upon analyzing your needs, can extend this list and create and tune an APS rule to your specific needs. We talked about analysis using statistics. There are a great number of reports that are included with PreActor. We can also build more reports, and they come with a number of presentation forms, whether it's tabular or bar chart or pie chart. And you may say, we are looking to minimize the cost of the individual orders. You may say, we're trying to minimize the make span of the entire schedule. We're trying to minimize wait time of materials. So again, you can pick the reports that emphasize those criteria that are most important to you, and you can turn to those reports to compare different schedules when doing what-if analysis. You can view the schedule the way that works for your business. That might take a tabular form. That might take the form of a Gantt chart, and either or both might be projected onto screens in the facility, or sent to a manager, or simply displayed for the benefit of the production controller prior to releasing the schedule. And again, these can assist with the what-if analysis. So really, automated advanced planning and scheduling can deliver a lot of benefits, and in our view, PreActor can deliver those benefits as well or better than any other product on the market.